It's like that's because I think all software engineers, people always are like, oh, you guys are gonna get replaced by LLMs. I'm like, weirdly enough, I think the part of me that's an engineer is good. That means we won. That means like we successfully completed the true. But no one handwrites compilers anymore. You don't want to have to think. People don't even write compilers anymore. Like people used to. I've written a compiler. I've written a C compiler. Like people used to write compilers as like a learning experience, and now it's like that's all just a mystery. And so it's yeah, but it's good at the same time. It's good that like you don't have to think about those things. You can just write code. And if we can get AI to do all of that, would be wonderful. And in a weird way, I think there's another angle is that like and this is something that's not talked about that much, but the scale of software systems is getting weird, right? Even in like regular mid-sized startups, the code base is hard to get your head around, but in like a Google or an Amazon, it's like actually reaching the sort of complexity balance of like, how do you write software at that scale? And there is part of me that thinks like maybe there is capabilities that we can do with AI that are going to unlock some of that, right? One of my other like weird hobby projects is I'm interested in formal theorem proving. And that's an interesting thing because in a formal theorem, you specify the axioms in code. It's actually called Haskell if anyone's a functional programming fan. There's a language called Lean that's very similar to that. But what's neat is mathematicians will use these. Very few. It's actually not as big of a thing in math as you think because it's hard. It takes a lot of skills to do it. But there's proofs that these things generate that are terabytes of data. And that's the only proof. There's this assumption we have in our heads that a mathematical proof is a straightforward thing that makes sense.